Alright, so let us solve the problem posted this afternoon. The first one is solve which has a higher effusion rate between chlorine and iodine. So as you can see, the information about the chlorine is given here as well as the iodine. Okay, and for number 2, hydrogen effuses at 4.6 compared to gas X. What is the molar mass of gas X? So information is already given here for hydrogen, and if you do not have a printed periodic table, you can access it in this website. That is an interactive periodic table wherein it can compute the molar mass of a given element or a compound. Right, so let's have number 1. Okay, so for this problem, we have two elements that we're supposed to compare. The first one is chlorine, and then the second one is iodine. Okay, so for the molar mass of chlorine atom, so there are two chlorine atoms present here or given here. So let's have, this is the molar mass, okay, for chlorine, which is 35.45 times 2. Bakit dalawa? Kasi meron tayong dalawa dito, which will give us 70.9 grams per mole. The second one is iodine. So nandito yung information natin for iodine. The molar mass is 126.9 or 0.90 times 2 because dalawa rin ulit sila dito. Okay? So this will give us 253.80 grams per mole. Alright. Now, this is the first step, assigning the molar mass or determining the molar mass of the given elements. Okay. So the given elements here have chlorine and iodine. Right? So for step 2, let us assign the rate. Let rate A be chlorine, right? And let our rate sub B is iodine, right? Iodine. Okay. So for step 3, so we have to apply the Graham's law of effusion. Okay. So we now have R, and this is chlorine, Cl2 over by R sub by I2 or iodine. So again, that's a rate of chlorine and rate of iodine is equals to, you have to remember that they are inversely proportional, the mass and the rate. So the one on top here should be the molecular mass, or the molar mass rather, of iodine, and the molar mass of iodine is 253.8, so 253.8 grams per mole. And then the one at the bottom should be the molar mass of chlorine, which is 70.9. Right, so let's solve this using our calculator. Okay. So this gives us 1.889. Right, so this means that chlorine has a higher effusion rate compared to iodine. Well, obviously because we can easily predict by looking at their mass. Remember, the more massive the material is, the slower they move. The lighter the material is, the faster it will move. Alright, let's go to problem number 2. Again, we have to identify the molar mass of the given element. Okay, so that is hydrogen, and this is the information about hydrogen gas. So that is 1.008 times 2. You might be wondering why times 2. It says here times 2. Okay, because hydrogen is a diatomic. Okay, diatomic molecule. So this will give us 2.016 grams per mole. And then the second one, we do not know what the molar mass of gas X is. So let's leave it there muna. Okay? The second step is to determine or assign the rates of these two gases. Right? So let rate A be our hydrogen gas, okay, which is 4.6. Okay, that is hydrogen. Rate is 4.6. And then the rate for the gas X is 1. Right? Since we do not have a precise rate value for gas X, we're still going to fall with 4.6:1 ratio. Okay? So, the next one, apply the Gle equation. Right? So, that is 4.6 over 1 is equals to the square root of x over by 2.016. Okay, now we want to remove the square root sign, so we can do that by squaring both terms. So square natin to, use a parenthesis, squared, and then square din natin to. Okay, now what is left? Tatanggal to, tatanggal yan. So we now have 4.6 squared is equals to x over by 2.016. So let me clear this. Right? Cross multiply. Okay, so there's an over 1, so we have x is equals to 4.6 squared multiplied by 2.016. Okay, so let me get my calculator. So that's 4.6 squared. Okay, 2.016. And that gives us 42. Oh, sorry. That gives us 42.65 grams per mole. So this is the molar mass of our gas X. Okay. Let me highlight it. Okay, so this is the molar mass. Alright, so tomorrow we'll have your SA, right? So be ready.